Welcome to technical session number 36. We're going to be talking about implementing hard drives. We're going to be getting into a few different things. We're going to be talking about explaining the purpose and methods of hard drive partitioning. And what exactly does that mean? Just in time for the lab you're going to have to experience on Coursera. We're going to be explaining the purpose and methods of hard drive formatting. Why we do it, what does it do? And then identify some quick common problems with hard drives, although some of this will be a review of what we talked about yesterday when we were talking about troubleshooting hardware and networks. So we'll get into this a little bit at a time. BSMs we want to keep in mind for this particular session are going to be teamwork, as IT is a team sport. Our skills will vary. We do need to rely upon others, as nobody is the pinnacle of all knowledge, all things IT. And on each team you will operate, you'll have varying skill sets. Some will be better at telecom, some will be better at networking, some will be better at security, and what have you. And you'll need to lean on each other and learn from each other. And that is the kind of mix that will make very strong teams. If everybody has the same skill sets, you'll also have the same weaknesses, right? Also, with regards to learning, keep in mind persistence. If we are easily figuring out things and succeeding at everything we're trying, the first time we do it, we're not pushing ourselves. We're only picking the easiest path. So we need to find ways to challenge ourselves, to push through. What do we do when we get knocked down? Do we take our ball and go home? Or do we get up and push forward? All right. Partitioning. What exactly do we mean when we say this? It's basically a way that we can break up a physical drive into smaller and smaller units called partitions. Hard drives must have Hard drives must have at least one partition, and depending on the type of OS you use, will determine which kind you need. And partitions can also be used to create and utilize multiple operating systems on the same hard drive. And you can utilize one per partition unless you're using virtualization, and that's a totally different animal. So, 3 partitioning methods that you will come across within Windows is the MBR, or master boot record. You have the Windows proprietary dynamic partitioning scheme, or dynamic disk, which tends to be the most common. And then we have the GUID, or globally unique identifier partitioning table. This is a fun one, an acronym within an acronym. Fun days. So that would be GPT. So GUID partitioning table. Let's talk about these individually. All right. Nick, can you read for us, please, sir?
Hard drives using MBR, or partitioning scheme, have a tiny bit of data in its first sector that is also called master boot record. MBR also contains the partition table, which describes the number and the size of partitioning on the disk. MBR partitioning table support up to 4 partitioning. When PC boots up to BIOS.
Go ahead. You're doing good.
When the PC up to BIOS looks at the first sector of the hard drives for instructions in the partitions table, determine which partitions contains the active operating system.
Awesome. Thank you, Nick. So essentially we get 4 partitions maximum out of an MBR partitioning scheme. That's what we get. And it takes a tiny bit of data in the first sector of that drive, which has that table called the MBR, and it tells the computer how many partitions, where they are, how big they are. And then the BIOS would go to that first sector, and then it would be able to identify which of the partitions has the operating system, the active one we wish to use, on it. Can anybody think of a reason why it would be a bad idea to just put the MBR in the first sector of the drive every time? Anybody think of a reason why that would be bad?
And sir, what was the question again?
Why is it a bad idea to put that MBR or master boot record table in the first sector of every drive?
Possibly risk of corruption due to data written or stuff like that.
Risk of corruption. Okay. Anything else? I mean, wouldn't that risk also apply if I put it anywhere on the drive?
I think because of the way it writes data from the beginning to the top might be why. So the farther away you are from the middle, the least likely you're going to encounter data being written.
Interesting. Any other theories? No theories. Because it boots first. Okay.
In case you have other data that you want to, does it have anything to do with booting from another OS?
No. Let's think about this a different way. If I was a security professional and I handled physical security at people's houses, and I told them, you should always put your keys and safe in the first room on the right when you enter your house.
I don't know how to get hooked up.
Everybody's going to know where it is, right? So if we always put something in the exact same location, it's easy for people with ill intent to find it, right? I always love those YouTube ones. Like, here's the best place in your house to hide a safe. Like, not anymore. So if we always put something in the same location, it's easy to track the stuff down. And if I took your map of your drive and where the partitions were and where the operating system was held, and I deleted it, how easy do you think it's going to be for you to operate? Not very good, right? All right, so next one here. Let's see. Kaylee, can you read first, please?
Primary partitions. The MBR partition tables support two types of partitions, primary and extended. Primary partitions support bootable OS, while extended partitions are not bootable. A single MBR disk may have up to 4 primary partitions, or up to 3 primary partitions and 1 extended partition. Primary partitions are usually assigned a drive letter starting in C. Each primary partition on a single drive has a special setting stored in the partition table called active that determines the active partition. Grub Boot Manager is used to control multi-boot setups with one Linux OS.
There we go. So again, 4 partitions, we can have 4 primaries or 3 primaries and an extended. And only primaries can hold operating systems. So, and if we want to do a multi-boot, Grub Boot Manager is a just fine one we can use. So it allows us to select upon startup which one we wish to go into, or we can have an active one set automatically and we go into that one unless otherwise selected. All right. So, extended partitions. So an extended partition can contain multiple logical drives, and you can give each of them a drive letter, if you wish. So logical drive works kind of like a primary partition, but you can't boot from it. And an extended partition, we can actually pull in extra drives as well. So we can span across multiple drives if we wish. And then we can create drive letters for them specifically. Dynamic disks. So another partitioning type we can use. These create structures called volumes. The number of volumes can be created in a hard drive is not restricted. So as many as you wish to add, as much complexity as you want to add to your drive or to your day trying to find stuff, you can do it. It also allows us to implement RAID. And then we talked about spanning, where you go across multiple drives. Striping across multiple drives, which is what? What is striping?
RAID 0.
RAID 0. There we go. Mirroring, what's that?
RAID 1.
RAID 1. And then we get striping with parity, which is?
Redundancy support. Redundancy support.
It doesn't say it supports it.
Oh, RAID 10.
Yeah, the RAID 5.
Striping with parity. Striping with parity.
RAID 5.
RAID 5.
RAID 5. RAID 10 is not supported here. Big frowny face. So no RAID 10. So we have a simple partition spanned across multiple drives, striped, which is our RAID 0, mirrored RAID 1, and then RAID 5, but that is strictly with Windows servers with this. So there we go. On to GUID, or Globally Unique Identifier Partitioning Table. Acronym within an acronym just makes the fun continue. Lost my randomizer there. There we go. I hate being restrained by a cord. All right, so it's similar to the MBR, but it improves upon the limitations. Remember, we only could do 4 before. Now we can do up to 128, because goodness, who would want to do more partitions than that on their hard drive? The MBR maximum could hold a partition of 2.2 terabytes. And though that seemed like a giant amount of data back in the early 2000s, now we're just getting started, 2.2 terabytes. So the ability to manage partitions larger than that, we need to have the GUID GPT.
What
So,
it mean, like it's telling unlimited number of partition, but window limited to 128.
yes, Windows limits it to 128. In Linux, if you're using the GUID in Linux, you can do as many as your heart desires. Windows does a similar thing with like RAM modules as well. And it just makes it easier. I guess for them to maintain. Right.
There was a question related to the first point.
Where's chat? I lost my chat. What was that, Majid?
I believe it was a question on Coursera or on LabSim, like related with this first point, like unlimited partitions.
Yes.
And-
So yeah, it's in theory you have unlimited, but Windows limits you to 128. So it's like theoretical limits versus, you know,
Okay, thank you.
operating system limits. All right, so GPT, is arranged by LBA instead of sectors themselves. Let's see here. Sorry. So, and LBA stands for, was it L logical block addressing? So LBA, logical block addressing rather than sectors themselves. LBA 0 is the protected MBR, in theory, a recreation of the master boot record. So utilities and all that stuff know it's a GPT drive, and it doesn't mistakenly overwrite that information. So GPT uses a header and a partition entry array. Both are located at the beginning and end of the drive. So even if they come in and they hit the beginning, or the beginning becomes a bad sector, we have another one located at the end. So it adds a little bit more redundancy than just having the one map. So we have one map and a backup. Makes it a little bit more secure for us. All right, Windows can only boot from GPT if you are utilizing UEFI, so no BIOS. And you have to be using a 64-bit version. Sorry, 32s. And we're only really concerned with Windows 10 and 11. We're not really concerned about 8.1, 8.7, and Vista. So all versions of Windows 10 can have it, with the exception of the 32s. The new Windows 11 no longer allows 32s. So, you know, we're slowly kind of legacying that type of architecture out. Other partitions that are used, Linux has built-in support for GPT, which is nice. They have an older one called Bure, or you can use UEFI firmware. Apple's Intel's no longer uses APT or Apple partition table. They are kind of folding into the GPT structure as well. So everybody's getting on board with GPT. Kind of nice, I guess. All right. When do we partition? Why on earth would we want to do this? Well, when we're installing an operating system, or when we're adding a new drive to an existing system. All right, so when we're installing a new OS, the program is going to ask, how do we want to partition the drive? Most of us just say automatically, just go for it. But if we're doing a multi-boot system, we may not want to set it up that way. We're going to have to think ahead and preset our partitions before we add the other operating systems. For adding a new hard drive to an existing system, they have built-in tools that can help us partition it, called disk management. Yay, right here. Then you have the fdisk options over here as well. So you can do it in command line or GUI. Most people prefer to do it in GUI, although you'll get your opportunity to do it in command line as well, and get to partition in Linux, which most people find fun. The looks on y'all's faces tell me you don't believe me. That's harsh. Would I mislead you? Yes. All right. So, hard drive formatting overview. So formatting essentially does two basic things. It's creating a map, a file system. And then it's going to make a root directory in that file system. And that kind of builds that foundation upon where our files and folders and how everything is going to hold the data or organize the data. Now, there's some older ones that we got to go through, but we're going to talk about various versions of file systems that are used, leading up to the most modern one, which is pretty much standard today. So a lot of the formatting and stuff can be done in disk management. That's the GUI system we were talking about earlier. You can choose which type of formatting you want to use, And depending on the medium you're using, if you're just using a thumb drive, you may choose different medium than you would on your standard disk. In fact, if you're doing NTFS, it typically does not work on a thumb drive. So the current versions that are kind of out there floating around in the ether that we have to deal with are FAT16, FAT32, FAT64, also known as exFAT, and then the new technology file system, NTFS. All right, FAT16. This is probably one of the lower level allocation tables you can use. It stores information in sectors up to 512 bits of data, or bytes of data, excuse me. Now, here's the downfall of this. So each sector has to be 512 bytes. So if you're writing data and say you have 525 bytes of data that you need to write, well, it would write one sector and then start the next sector. And then as, you know, there's no other information to fill it, they just put zeros in there essentially, and it becomes wasted space. So you'll only use up a portion of that sector. So over time, this adds up as we add programs and stuff like that, and documents and all that kind of fun stuff. It becomes a very inefficient way to store data because you have all these wasted chunks of data. Now, so FAT is short for File Allocation Table. What this does is essentially creates a map for your system to find where everything is located, because it's not always, yeah, just look at the next sector, just look at the next sector, and you can add your program together. We have things that happen. Well, like what? Well, bad sectors. So maybe the next sector is no good. What do we do? How do we know where to go looking? Over time, we delete and add and delete and add and delete and add. And when we're adding programs, there may not be a block with enough space for us to put the one program in. So we have to break that program up into chunks. How do we know where to go find this stuff? So we use a file allocation table to do this. Now, each sector on this column can have a hexadecimal number from 0000 all the way up to FFFF. So 16 bits of data to kind of give us the information on it, which allows us 64,000 sectors that can be tracked. Seems like a lot, it's really not. So the right column will use information about the status of those sectors. So if the sector is good, you'd write it with 0000. If it's a bad sector, FFF7. Makes sense? We can write our own allocation table now. We're good to go. No more needed. Don't worry, we have examples. All right, so we talked about this. 512 bits per second, 64,000 sectors only gives us 32 megabytes. So we had to improve upon this. And we call it clustering. It enables format partitions larger than 32 megabytes because we really cannot do more, or cannot do nowadays less than 32 megabytes. That's barely an email at this point. So clustering refers to combining a set of contiguous sectors, and contiguous is basically just like all the things that are like need to go together or they're similar. So all the pieces of the document are the contiguous sectors of that document. And treat them as a single unit in the file allocation table. So it allows us to store much larger amounts of information, and the size of the cluster is not necessarily fixed, but we can get up to partitions of 2 gigabytes. Does not seem like a lot, but it works for things like thumb drives, and it does work for computers about 10, 15 years ago. No, sorry, 20 years ago. It's so sad when I went to college and I looked at somebody and was like, man, you've got a 1 gig hard drive. That's insane. I would never fill that up. Now we're like 20 gigs out of the gate. we have barely turned it on. We have 20 gigs used up. All right. What does a file allocation table look like? How does it work? What do we do? All right. So left-hand column gives us the cluster that it is. So it's the name of that sector. The status, if it has 0000, just means it's ready to be written on. It's open and available for business.
We
FFF
screenshot this. I'm sorry to interrupt.
Can you screenshot this or should you?
It showed we did.
I don't know, you tell me.
I think it's important.
Does it sound important?
It does.
It does, are you sure?
Yes.
Would I bring this stuff to your attention if it wasn't?
No, you wouldn't.
Yes. All right. So we got bad sectors. The thing basically to take away from this is open available sectors would start with 0000. Bad sectors are FFF7. And then over here, we have the names of it. Now, here's what we do. So the status, how does that change? Why is that important? If I'm adding a file and I start on cluster 3ABB, but it's too big for that cluster, the status tells me where to go looking next for the file. So it'll say 3ABC, which is the next sector down. So boom, I go down here. This is another chunk of my file. And then I look over here and it says 3ABE. Well, why not D? Well, we see FFF7 right here. What does that mean?
Bad sector.
Bad sector, right? So we can't write here. So it's telling us we have to go 3ABE, which is down here, to see the last bit of our file. And how do we know it's the last bit of our file? Because it goes FFFF. When we see 4F, that is the end of the file. So 4 zeros, open and available to write on. FFF7, bad sector. FFFF, file is done. Does this make sense? And over
You
here,
said FFF is that the file's done.
yes, that's the end of the file.
Final. Okay, perfect. That's how I remember
Yeah.
it. Thank
So
you.
if I have a document and it's going to take up 3 clusters, here's the first cluster, the second cluster, and then it drops down to this cluster, and then it ends. Because remember, the status tells me where do I go looking next to see the rest of this data. Now, why defragmenting is important, let's kind of look here. So we're writing a file and say there isn't a big enough section for us to put that file in. So we have our first section in 3ABB. We look, our next cluster to go to is 3ABC. We go to 3ABC right here. It says go to 3ABE, which is not the next one because it's a damaged sector. Then we skip over that. We go to 3ABE. And then it says 3AC4 because another file was already here. So we have to skip over that entire file, 3AC4, and then it goes 3AC5, boom, down to 3AC5, 3AC6, boom, down to 3AC6, and then FFFF, end of the file. So in this instance, the read-write head on our hard drive is having to jump around quite a bit, right? This is why defragmentation is important, because it rewrites these files so that they're going to be sitting right next to each other instead of having to jump all around to find the pieces. Make sense?
Yeah. And 0000 means it's available, right?
Yeah, it's available and ready for you to write to it.
Okay.
So that would be in the status. So it means it's an open and available sector to write to. FFF7, bad sector, do not write. FFFF, end of the current file. Questions on this? FAT16 experts, we can look at a file allocation table now and go, yep, I got this.
So this FFFF, even if we format the whole hard disk again, it will be remain in the same like this.
Well, the FFF7 would, because that's a bad sector, right?
Yeah.
But the FFFF would not. That's going to move around because that's where the files end. Does that make sense?
So
Sort of. So just think of basically, you know, FFFF just means end of document or end of file or end of program. And so I don't need to go looking for any other sectors to try to finish the program. I've gotten all my information. Right?
okay. Thank you.
The key thing with file allocation tables is try not to overthink it. They tend to be pretty straightforward, thankfully. All right, let's move it up a little bit. FAT32. New and improved version of FAT16 uses 32 bits to describe each sector. So the file allocation tables, instead of using 16, now uses 32 bits in its allocation table. Supports partitions up to 2 whole terabytes, allowing more efficient use of disk space without the need to make multiple small partitions like you would with a FAT16. But it still needs to be defragmented as regularly as a FAT16 does. It's still typically used today, commonly used in USB drives, 32 gigs or smaller. Is there a FAT64? That is a wonderful question, Justin. We will get into that right here, FAT64. So we'll talk about that in a minute. All right. NTFS, or New Technology File System, one of the most common file systems used today. It is far more complex and powerful than the FAT16s or FAT32s. It offers a bunch of improvements upon them, including things like redundancy, security, compression, encryption, disk quotas, where you can say you can only use so much, cluster sizing, so we can adjust the size of our clusters. And it is hands down the most common one being used today. Cannot be used on externals and flash drives because its security and encryption can make access very difficult between drive systems. You know, like if you're moving from a drive from one to the other, big problems. All right, structure. NTFS uses the enhanced file allocation table called the MFT, or master file table or filled table. This keeps copies of the MFT in the middle of the disk. So you remember the GPT kept it like on either end. You had the MBR that kept it in the beginning. This keeps it in the middle, making it much harder to locate for somebody with ill intent. All right. Security. Nice thing about NTFS is it views individual files and folders as objects. And we can provide or allocate security to those individual objects using an ACL. Where do we hear this before? Where have we heard of the ACL before? Firewall. There we go, firewall. So NTFS can utilize an ACL with regards to your documents and files. Who can see them? Can they be transferred? Can they be viewed? What have you? Compression. We can take individual files and folders now and compress them to save space on our hard drives. Problem with compression, it makes us accessing those files much slower. It's kind of like encryption in that sense. If we have to compress and decompress something every time we're going to use it, it's going to eat up processing time and take more time to access, utilize, and then save. Same thing with encryption. Now, we talked about BitLocker, which is that full drive encryption using the wonderful piece of firmware that is soldered onto our motherboard, which is called what?
TPM,
TPM. Excellent. What does it stand for?
trusted platform
Module.
module.
Module. There we go. Trusted platform module. So, which is awesome, but encrypting and decrypting an entire drive every time we need to utilize something is really processor heavy. And I don't really care if my Candy Crush high score is encrypted. I want everybody to know my Candy Crush high score, so I'd rather not hide that information. But I do have other stuff like taxes and accounting information, investments and stuff like that. I'd rather have that stuff encrypted. So I can actually go down to the individual file or document level and encrypt just those files using EFS, the encryption file system. Next, disk quotas. Some people like to save everything, you know, it's like they go to their Netflix wish list or watch list and it's 10,000 TV shows they're never going to watch. They just keep adding stuff to it, but never really taking anything away. Well, there's people like that in offices too, who just kind of save every little document they can get their hands on and it chews through all of your space and stuff like that. So the NTFS file system allows us to set quotas on a multi-user shared drive system. I know you like saving all this stuff every time you see it, every PowerPoint, every, you know, media release from everybody we interact with. But I'm going to limit you to 2 gigs of space on the shared drive. So we can set quotas and say this is the maximum amount of space you can take up on the drive. And this prevents any single user from basically taking over an entire shared drive. All right, cluster sizes. So awesomely, NTFS allows us to adjust the cluster size. By default, partitions are up to 16 terabytes. Pretty awesome. On a dynamic disk though. On a basic disk, we can get up to 2. Now, according to crowd demands, we talk about FAT64. Yes, it's a real thing. It does exist. It's also known as exFAT. This supports drives up to 2 terabytes, and you could have individual files as large as 4 gigabytes. So, oh, excuse me, since FAT32 only does this, sorry. FAT64 supports a file up to 16 exabytes. Anybody want to look up how big an exabyte is? And a theoretical partition limit of 64 zettabytes. Who wants to tell me how big an exabyte and a zettabyte is? So you can get an idea of how big this is.
It's 1,000 petabytes.
What's a petabyte? We got to work our way backwards.
It's like 1,000 terabytes.
1,000 terabytes. So it's 1,000 times 1,000, right?
Yep.
It's the length of 2 football fields.
And that is that an exabyte or a zettabyte?
Exabyte.
Exabyte. How big is a zettabyte? If I'm not mistaken, I think there's only like 4 zettabytes of information total that has been produced, like on Earth.
I'm not gonna lie, I don't even know how to say this. I was
Copy
looking
it
at
and
the
drop it in
wrong
chat.
thing. It said it's 1 billion terabytes.
1 billion terabytes?
Yeah.
That's a lot of information. So theoretical limit, 16 exabytes with a limit of 64 zettabytes. Meaning nobody's created a drive this big. It's kind of like the IP version 6 address where we have 340 undecillion addresses, which is more than there are grains of sand on the planet. We could attach a NIC to every grain of sand on the planet and still wouldn't run out of addresses. So very large external drives would use stuff like this because they can't use NTFS. It gives us the opportunity to use much, much larger drive systems. All right. Good stuff. Linux kind of has their own deal. They can read and write to NTFS, FAT32, FAT64, and then the old HTF from Mac, but they use their own file systems called ext4, 3, and 2. 4 is the more common one, or the more modern one, excuse me. Nice thing about the ext4, supports volumes up to 1 exabyte, yay, and individual files up to 16 terabytes. And then your directories can contain up to 64,000 subdirectories, which is a little ridiculous. All right. Other formatting options, optical drives, you have CDFS or UDF, and that is CDFS is CD-ROM file system. I want you to remember this because this is one of those ones that come up on an exam and you look at it and go, that's too easy. It's not that. And so you discount it because it's a little too obvious of an answer. And that is the CD file system. And then you have UDF, which is the universal disk format, which is more the DVD Blu-ray formatting style. I know people really aren't using CDs much anymore, but you know, you still have the hobbyists out there making it so we still have to remember. All right. I mean, yeah, Jose, that's the thing is like when I talk about the 4 exabyte or zettabytes, that includes the stuff on YouTube. So all of the data that we have stored total, I think only amounts to about 4 zettabytes globally. I could be wrong on that, but I think I heard a statistic where it was like that. All right, NFS or network file system. This was originally developed by Sun Microsystems. You know, the people who brought us Oracle. Makes it possible for files on the network to be accessed easily as if they're stored on your local computers, which is great. So even if the host computer is using a different OS, like so if your host is using a Mac OS and you're using Windows, or you're using Mac and they're using Windows, the network still is able to function and allow you to utilize these files. That is network file system. All right, so real quick, what do we think formatting does? When you hear formatting, what do you think that does to your hard drive?
Condense the space.
So we said wipes it, deletes it, change, how so? Erase, clears the data, reset, calibrate, readjust, okay.
Doesn't formatting it change it so that like it operates based on like the system that you're using it for?
Yeah, that could be one way, you know, but say like I'm going to reformat a hard drive. What am I doing to that hard drive? So you said calibrate it so it works with the operating system, or? Okay. So those you saying erase and delete. So if I got next week's lottery numbers and I don't want to share them with anybody, and people are coming to try to take it, and I go in and I just type in format C:, is that going to get rid of the lottery numbers? They're stored in the C drive, yes. Okay. What if I told you formatting erases nothing? Nothing, doesn't erase anything. All formatting does is get rid of the allocation table and then set all the sectors in the drive to 0, saying they're open to being reused. So all we're doing really is removing the map and then saying it's cool to write over these sectors if you want. But the data is still there. It hasn't been removed. So that's all formatting does. Quick format just quickly goes in, erases the table, sets everything to 0, and then you're good to go. Then you can just start from there. Then you have full format, which does the exact same thing, but it also does a check on the hard drive to make sure there's no bad sectors or errors. And if there are, marks them with the infamous FFF7 so that we cannot write to those sectors. So that's the difference between quick format and full format, is simply checking the hard drive for bad sectors. And all formatting does is erase our table so that it's harder to put the data back together. But the data still exists. We'll get into destruction and disposal soon. All right. Data management tool, disk management. So from here, I'm sure you have, there is a lab in test out that you'll do where you get to create a spanned volume as well as RAID. And then they also have a lab for this in Coursera, so double fun. But this is what it looks like in the GUI version, where you can go in, create extra partitions if you wish, span across multiple volumes, set up RAID if you wish, all that kind of fun stuff from this one pretty straightforward, relatively easy to use program. And it is disk management. Questions on this? So this is where you would go if you wanted to format a thumb drive or a CD-ROM or your hard drive or any of that stuff. All that stuff would be done from disk management. We did it already for LabSim. Awesome, Andre. I got y'all ahead of the time, ahead of the game. It's cool. I'm a good Jedi like that. All right. Let's see. Here we go. Troubleshooting the implementation and partitioning. So partitioning generally falls in, problems with it tend to fall in 2 basic categories. 1, failed to happen at all, or 2, the wrong size. Both cases, we would open disk management and do the partition correctly. If the problem is in a secondary drive, not your primary drive, if it is in your main one, the partition, we have to use the command line in order to recorrect the partition in the main one. So straightforward. And that's the fdisk command. Gets you into the partitioning menu in CLI. All right, failing to format. Makes it unable to hold data, which is kind of, sad. And then accessing the drive in Windows will result in this drive is not accessible, error, or invalid media type. And also corrupted files on this can create the invalid media error. And I've had instances where I have formatted a drive and the drive is not accessible on, say, a Mac, but then I would go to a Windows machine and it's there. The formatting took, it's accessible, and for some reason it just won't read on the Mac, but it will on Windows, and vice versa. So kind of weird. I'll get the invalid or not accessible or invalid media type every time I use these thumb drives. It's weird. I have to, I've had it happen to like 5 or 6 of them, and then I have to mark them for Windows or for Mac OS. And that's after multiple attempts to reformat to see if I could fix the problem. All right, physical problems. Several ways: read-write failures, lots of grinding noises. Again, this is one of those noises when you hear it once, you will never remember it, or you'll never forget it. And the other one is complete drive failure. The drive just seems to disappear. So if they make any of the following sounds, be wary, it's about to die. That's that continuous high-pitched squeal. That is something grinding on the platter. Loud clicking noises, a short pause, and then another series of clicks. If you're hearing a constant clicking, that could also be debris in your fan. So every time the fan turns on, you hear the click, 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 click. If it's rhythmic and continuous, that tends to be debris in your fan. This does happen a lot when you open up the computer to do some work in there and you accidentally drop a screw into the fan. Happens a lot. And then you get the repetitive sound. Continuous grinding or rumbling, which is very disconcerting coming from your computer. At this point, back up everything now, not tomorrow, not next week, not 3 hours from now. Now, get it backed up. Replace the drive as soon as you can. So when the drive of the operating system dies, system's going to lock up and it'll give you no boot device present. Big frowny face. If you have a secondary drive, it will stop show, or if it's a secondary drive, it'll stop showing up in your Windows Explorer. So when you go looking for the drive, it's just not there. In both of those cases, make sure your cables are connected properly because they can become dislodged. And rather than running out and trying to swap out the drive and buy a new drive, first check and see if the drive is properly hooked up. After that, then we can start talking about the bad things that may have happened. And quiz. And with that, we come to the end of our technical session of the week. We should now be able to explain the purpose and methods of hard drive partitioning. That we're basically taking a whole drive, breaking it down into smaller and smaller chunks. Explain the purpose and methods of hard drive formatting. It doesn't erase the drive. Just removes the file allocation table. And the difference between a quick and a full format is essentially scanning the disk to see if there are any errors, bad sectors, and identify common hard drive problems and explain how to maintain and troubleshoot these issues. Questions, comments, concerns, complaints, revelations.
If a disk we can put some passwords, we still can format it or not?
If the what?
If a disk have a security.
Security passwords. Honestly, I'm not sure because it may not allow you to access the disk because you don't have the password. If you have the administrative password of the computer, then yes, it likely will. But security passwords. I mean, it'll let you erase it. I'm not sure about formatting. It's a good question. I'm gonna have to check on that one and get back to you.
And yesterday you mentioned some kind of program for security, and you said when you find you will share the link. So I'm just curious.
What was the name of the program?
I don't remember. It was some kind of a security or something.
Oh,
We
you're talking about
did-
the one where you could make your own networks?
Yeah, exactly. Yeah.
Okay, yes, I am still looking for that one. So it's in my CYSA notebook, and so I'm trying to find where I wrote it down.
Okay. Thank you.
So I have not forgotten about that one. That's where we could create, and it's like a virtual machine, but for a whole network. Right.
It's same like packet tracer.
No, I don't think it's the same as Packet Tracer. There's a lot of different Packet Tracer programs too. So, all right.